Okay, good morning, everybody. My name is Peter Arras. I'm going to give a seminar about vehicle propulsion systems and the energy demand in the modern car and see how it impacts the car industry and what comes with it. Okay, this is just the abstract. That's what you also had. So it's the world of personal transportation is facing a lot of challenges because there is a lot of cars in the world, and they take away a lot of resources from the world, materials to make the car, fossil fuels to drive the car, and space on the land. So we end up in traffic jams. We have problems parking the car in the city. So there is a lot of fuss about it. And in this lecture, we are going to look specifically a little bit on the energy demand in a car. Because energy demand, if we look at it, this is one of the big drivers. If we want to cut on fuel demands, we will have to see that we need less energy to drive the car or look for alternative sources. So then it will become clear that we need some disruptive change to do this if we want to safeguard some personal transport in the future. And we will also have a look at new legislation and standards which force automobile builders to explore new pathways to fuel economy. Okay, so in the overview of my lecture, I will first say a couple of words about my home university and who I am, and then give an introduction on a car as a commodity addiction, about energy resources, battery resources, and some indications for pathways to better fuel economy. So I work for a university in Belgium. It's KU Leuven, Catholic University of Leuven. It is a very old university. It's one of the oldest of Europe. It was founded nearly 600 years ago in 1425 by the Pope. More or less, it's the biggest university in Belgium. We have about 57,000 students, more or less. We have a lot of staff. We have academic staff, about 12,000 people working in the university, and another 8,000 extra in the university hospitals, because we have a very big medical branch in the university, as we will see. KU Leuven is also a very innovative university. We are in the rankings for the most innovative university of Europe. For 5 times in a row, we are number 1. So we'll see. So we see some pictures from the university. This is the University Library for Humanities. This is the inside of the library. This castle is also an iconic building of KU Leuven. That's where Dean's Office of Engineering Faculties resides. KU Leuven is a comprehensive university. It means it does like everything. It's not technical, it's not humanities, it's everything. We have 16 faculties altogether in 3 big groups. There is a group of humanities and social science. There is a group of biomedical science, in which is also doctors and so on. And then we have the group of science, engineering, and technology. And in this group, is the biggest group, we have 5 faculties: science faculty, engineering, technology faculty, engineering science faculty, architecture and bioengineering. And I'm from engineering technology faculty, just to situate where I come from. Now, we have been working with Ukraine for many, many years, as already also Galina told you. We started a long time ago with Tempus Project Christ. It was with Kiev Polytechnic, Kharkiv, KI, and University in Dnipro. And then came Tempus Promeng, in which we met for the first time, that time ZNTU. We had Tempus Emmating with a number of partners, also Lviv and Mariupol partners in Ukraine, and then another project which I participated. It's a Tempus Desire project, which ended a couple of years ago. And now currently we have a Key Action 2 project BioArt running, in which we are partner and ZNTU is partner. And then started the workforce project, just started a couple of days ago, and we look forward to collaborating a lot again with now NUZP of National University Zaporizhzhia Polytechnic. Besides these projects, we also do we offer possibilities for Key Action 107 teaching and student exchange. And until now, we have more than 25 students and staff coming over to Belgium at KU Leuven to have a student study experience or teaching experience for the staff. Some of your colleagues or students, they remain in Belgium. We have about 5 students from ZNTU working in Belgium, which is 2 in KU Leuven and another PhD student in KU Leuven. So it's a very interesting program for students too and for staff. I myself, I was promoted to be honorary professor in ZNTU in 2016. And we also work a lot on common research paper, and so that we elaborate on the different aspects, of course, of collaboration. Okay, now to situate a little bit the lecture and how we, what kind of how we work with this, we are very much into like electric cars and hybrid cars and so on. We also have a couple of student teams in the faculty participating in events all over the world with their cars. So our solar team, it's the solar team in cooperation with Punch Powertrain. And they won last year the Atacama Desert Race in 2019 in Chile, which is a very interesting race for an electric car because it's like 2,600 kilometers and it comes from sea level, if you know Chile on the map, up to the Andes Mountains, 3,400 meters above sea level, and big slopes up to nearly 15%, which is all of this is a big challenge for an electric car. So the electric car we see here, it's a solar panel car. So it's driven only by solar panels and batteries. Later, the same car won the solar race in Australia. So we're doing very well. It's in our faculty. Another thing which we participate is Formula Student competition, which is an international engineering competition in which student teams build and race a car. And we race electric cars for over the last 7 years. So students have about 12 months to design and build a car and race it. You will see some of the models of the car. Which was done over the last year. So it's an electric car. It's a 4-wheel drive with direct drives on the wheels. Everything is made in-house and designed by the students. So it's a very interesting thing. So all students can participate for master thesis and so on. So specifically, my students, they are working on aerodynamics, gearbox design, motor casings, battery casings, body, space frame. So anything concerned mechanical design is my own students working on this. Okay, so to show that we have some experience there and that we have a quite good view on the market. So let's come to the seminar now itself. So why the seminar and what's behind it? Well, there is a lot of cars in the world and they impact on everyday's life. Yeah. It brings freedom to users. People who have a car, they can go wherever they want, despite traffic jams, of course. But it brings some freedom. You're more independent. But cars also have a huge impact on environment. Pollution in the cities is a very important part of it comes from traffic. Cars also consume a lot of resources. As I told, metals to make it now precious metals to make batteries and electric engines for newer cars. They use fossil fuels, so all of these resources, which is limited in the world. So it creates a problem. And also, for different people, a car has a different appeal. Some people think on cars only about sports car or SUVs or family cars or just functional cars to transport themselves. So there is a different appeal, and this also complicates a little bit all of these things here. So the world is facing a big problem with this number of cars. Because of the space use, the traffic jams, resources, and pollution. So we need to rethink maybe personal transport. And to show this, we see here some diagrams. And then the number of passenger cars and commercial vehicles in use worldwide is, see here, the numbers going up from 2006 all the way to 2015. And we see we have more than 1.3 billion cars by now in the world. If you put them end to end, it's a lot of kilometers, which will circle Earth a couple of times. Yeah. And also we see a growth in commercial vehicles. Yeah. So there is more road transport anyhow. And as we see the global car sales in the world, this reaches about 77, 78. So nearly 80 million cars each year are sold. That's a big pile of materials which you have there. And this will keep rising because if you look at it, there's these diagrams which show that the number of cars in a society will grow if the welfare in society grows. Yeah? So if you look at the gross amount of money that people can spend, people who are countries where the average income is low, they have lesser cars, of course, and people where average income is bigger. So we see that it's like USA, Europe, and so on. There we have kind of reached a limit, and it stabilizes there at about 700 to 800 cars per 1,000 people. In emerging countries, so which is also like Ukraine, Russia, but the Far East, China, Brazil, they have still a lower income, but also the numbers rise, and it will rise until it stabilizes too. This means that there is a saturation in America and Europe, but in other countries in the world, it will still keep growing. Yeah. So, and this growth will, of course, take away more fuel and more resources. And there is, of course, a big problem because it puts a lot of pressure on it. Yeah? So we see here the numbers of family vehicles sold each year, and it grows exponentially in like a country like China, while the United States and Europe is stabilized. Yeah? But this growing amount of cars is of a big concern. Now, last year was a little bit, this year it is a little bit specific year because we have the COVID, but Corona, it gave a complete drop in car sales. If you look here during the months of this year, we see when there was the first wave of Corona in spring, the numbers of car sales plummeted. And it's very substantial. In Europe and America, there was a fall from 18 to 40%. Well, more or less between 20 and 40% of sales, which was cut. But this is only temporary because afterwards we see as soon as the first wave was more or less over, people started to buy cars again. And so this is only a temporary cut. The number of cars will keep on growing. Okay. So of course these cars need to be made. So we don't only have family cars, but also light commercial cars. This is also growing. And we see here a little dip. This dip is 2009. This is the financial crisis. Well, people had less money. People became unemployed. The sales of cars was substantially lower. But since then, it has been growing and growing and growing. So this is problematic. If you look at the energy consumption on the other hand, we also get some interesting facts. Energy consumption, on this slide, we see by transport mode in Europe from 1990 to 2015. We see for the road transport, this is this purple colored line. We see it grow, and then it stabilizes. It goes a little bit down, but it's growing again. Since 2014, we have the same. We have the same times. Here, 2008, 2009, there was the financial crisis. So transport, energy consumption ditched because there was lesser cars. People didn't drive the cars so much. So for international aviation, but also for the cars, of course, this is the same period. This year, 2008, 2009, we had a little bit going down, but for the rest, it's problematic. The biggest problematic line is this line here. This is international aviation. People started to take the airplane quite a lot over the last years as traveling became cheaper. But this gives a big problem in energy consumption because it's not very energy efficient airplane in comparison with the rest. So we see road transport, we see domestic aviation. This came down a little bit. Rail. So energy consumption by trains is going down and inland waterways is going down, because it becomes also more fuel efficient and so on. So why these cars? We have more cars, but less energy consumption is because cars got more fuel efficient. Cars got more fuel efficient over these years, and because there was at that time, starting from the millennium, there was a big promotion of diesel cars, which is inherently more fuel efficient than petrol cars. And so cars became more fuel efficient. So the average consumption per car got down, but we have more cars. But this has turned over in the last years. Okay. So besides energy consumption, we also have carbon dioxide emissions because this is the pollution. And then, we see here similar things. We see industry. Industry is doing pretty well on energy consumption. They are always blamed, but they are already for many years are getting much more fuel efficient so that it doesn't show here. They are doing their best. What's also problematic a little bit and is also being better is residential. This is like heating and so on. It's also much improved with isolation. But transport is on the rise. Now in EU they did a very strange trick because they put cars in the same thing as the airplanes. So it doesn't show that airplanes is polluting the most per user, let's say. Okay. And if we have for the transport, if we have the breakdown on CO2 emissions, then we see that about 60% of this pollution is created by personal cars. And then we have another 12% by light duty trucks, little vans and so on, heavy duty trucks, motorcycles. And then we have aviation. which is 13%, which is quite big because the users, most of the users of transports are here in absolute numbers of users, while civil aviation is for the more or less happy few who travel by airplane. So there is a big problem, and we can still manage a lot. We can do a lot if we improve the cars and the trucks about how they spend fuel. So we have more fuel efficient cars, but since Dieselgate took on, the number of the fuel consumptions is rising again. So our personal cars is of course important, and we see here the rise again. And this comes from, why is carbon dioxide emissions again on the rise? This comes from two things. The first thing is we had Dieselgate. So Volkswagen and other competitors, they tricked the exhaust tests, and they did kind of illegal things, of course. And as a result of that, diesel cars was done with. They're like getting forbidden in a lot of countries. We should all go back to petrol cars, but the petrol car creates much more carbon dioxide emission. On other emissions, it's different, but in carbon dioxide emissions is growing because we have less diesel cars. And a second thing, which is people want to buy bigger and bigger and heavier cars. So if we look at some of the numbers here, we see that the SUV compartment or sector, so sport utility vehicles, has been growing. We see these numbers, plus 50, 16, 17, 8, 12, so more or less plus 12 to 15%. More SUV cars than sedans and saloon cars for personal transport. And the bigger the car and the heavier the car, the bigger the problem of emissions. And another trend, of course, is what's been set over the last years and what we see in effect this year due to a lot of legislation is the number of electric cars and hybrid cars growing. So this is a counter movement for the carbon dioxide tailpipe emission. Not for emission in global, because they also need to have energy coming from somewhere. But the number of electric cars is growing all over Europe and all over the world. So if you look at the car and the transmission system in a car, the powertrain in a car, should we go to hybrid cars and battery electric vehicles, or can we keep up with combustion engines, which is an ICE, it's an internal combustion engine? Is it a hype or is it a necessity that we will go for a change? Because in the end, personal transport a car is nice to have, but you can also, it's not vital. You can do a lot without a car, with personal transport, with a bicycle maybe, or on foot. So a car is not a vital item in society. If we have to keep them, if we want to keep them, we will have to think about the future. And so we have the combustion engines. There is the oil problem. We have electric systems or combined systems. And in electric systems, we also have an energy problem because we need electricity. And where does electricity come from? It also creates probably or maybe some kind of pollution problem. And we will have a look at these too. So, and what's called in the advertisement a zero emission vehicle is not so zero emission, because electricity has to be made and batteries has to be made. So they also produce some environmental problems in this. Yeah? And the resources for batteries and for the electric cars also the charging problem, we cannot oversimplify. Yeah. The conclusion is not, it's not useful to do it. The conclusion is we should be careful not to oversimplify things and think about consequences of each of these things. So if we speak about a zero emission vehicle, like an electric vehicle, zero emission means the place where the car is, when you drive the car, there is zero tailpipe emission. There is no tailpipe where there is carbon dioxide coming from. But it can happen that it will be in another place, this emission. And for this, I looked at this. This is a nice website which you can look at. And you see, for every country, you can get there the numbers, how much carbon dioxide, what's the indication for the carbon dioxide numbers for each of these countries. And I took Ukraine a couple of days ago, and I look at this. And Ukraine is here. It's brown. It's got a carbon intensity of about 365 grams of carbon dioxide equivalent for each kilowatt hour that you make of electricity or use of electricity. Here is on the production side. This means if you look at an electric car like a Nissan Leaf or something, it uses something like 15 kilowatt hours for 100 kilometer. Yeah. So if you multiply it, 370 multiplied by 15, this is also quite a lot of carbon dioxide, which is used. Yeah, it's about 5.5 kilograms of carbon dioxide you have there. So for 100 kilometers. So it is not zero emission vehicle, an electric vehicle. It also causes this amount, at least, of carbon dioxide when producing the electricity. Now, Ukraine is doing quite okay because Ukraine's got a very huge nuclear reserve making it. But on the other hand, you still use a lot of coal to produce electricity, and this is not good. So if you look at other countries in Europe, we see like the worst in Europe is like Poland, because they make everything from coal. Germany, they have a lot of brown coal, lignite and coal. Estonia is also not doing very well. So in this website, you can see where it all comes from. So I would see still a big potential in Ukraine for wind and solar energy. Yeah, there is a big plains in Ukraine. There is it's a vast country. So there is a lot of potential on this to get this down. But so a zero emission vehicle like an electric car is not so zero emission. And you can do the same exercise with other countries in the world, of course. And they all show more or less the same. If you have an electric car, you should count something like 100 to 150 grams of carbon dioxide equivalent per kilometer. Yeah? So this is very different than zero emission. By the way, traditional internal combustion engine is much more. So we should be careful just comparing numbers. But this also shows that it's very useful to have electric cars in these like green countries. Huh? And the front runner is, of course, Norway, which is a special country because they have a lot of oil and still they have the most important part of sustainable energy in Europe. France, they got a lot of nuclear energy, which is also carbon dioxide neutral. Their electric cars is very, very good for the environment. While in Poland, it's probably better just to have an internal combustion engine because it's less polluting than using an electric car. That's what we see from these numbers. Second thing, which is problematic, is the resources to make batteries. Well, most of the batteries contain lithium chemical element. And already a number of years ago, they explored the future. And they said, okay, we see that the demand for lithium is growing at a rate of 12 or more % a year. But the production of lithium cannot keep up with this because it has to be mined. And you cannot you cannot go to the supermarket and buy a lithium mine. You have to build it. You have to find a place where you can mine lithium. So there is a shortage of lithium coming up. Okay, so this means if, like in Europe, we want to go up with electric cars from a 5% overall sale of electric cars to 30%, and Europe wants to promote this in 1 decade, in 10 years, there will not be enough lithium available. So the prices for lithium will rise. And you can recalculate how much you need. And you need about 3 kilograms of lithium carbonate to make a 1 kilowatt hour of usable battery capacity. So that means that at current rate where we mine lithium at the moment, we can make in the world about 4 to 5 million batteries of 16 kilowatt hours. This means for 100 kilometers. So if you have a Tesla, which drives for 600 kilometers, this is the equivalent of 5 cars driving only 100 kilometers. So one Tesla takes all the lithium which is necessary to have 5 cars. There is the range problem. We don't want to drive 600 kilometers in a row. Maybe less is better, and so then we can get more cars. So even with improvement of battery technology and so on in the near future, if we say we can cut 30% on what we need, we still will be only able to make 6 million cars, which have a 100 kilometer range. So this is a problem coming up. An extra problem in this is that it's monopolized by China. They buy all the lithium mines in the world. They have at the moment about 40% of lithium production already in their portfolio. So the resource problem is not only oil, but lithium is also becoming a problem. So here we see the data worldwide, how much of this material is available, and it's a projection. We're now 2020, we're now about here, and this is the lithium demand. And then we see that more or less in a couple of years' time, we will have the problem because the demand will be bigger than what's available. So, okay, we should be careful about this too, and think about it when we rethink what we want with cars. Now, legislation is, of course, an important thing, and the big players in the world and the continents which is very much into this is three. It's Europe, it's America, and you have in the Far East, you have Japan. They have very strict rules on exhaust. This comes from the fact that, like in Europe, you have a lot of cities and their pollution is problematic. Yeah. Similar in America, you have the big cities where the pollution is a problem. In the countryside, there is nobody living there. It doesn't make much sense. And you know this also from your own country, from like Ukraine. In the cities, you have the problem with pollution from cars. Outside of the cities, there is a lot of open space. It doesn't really matter. And Japan is similar. They have also very big cities. And they make strict rules on exhaust to force car builders to make more fuel economic cars. Yeah? And so now we are approaching 2021. And then the goal for passenger cars is that the average tailpipe numbers for carbon dioxide should be limited to 95 grams per kilometer. Yeah. And for light commercial vehicles, so vans and so on, 147. Up until now, it was 130 and 187. And in the future, it will also go down, more down, because you can't see it really in the numbers, but what is there is a penalty. There is penalties for car makers, and these penalties, they come into use in 2021. That's why at this moment, this year, if you look at the market for cars, there is a lot of new electric and hybrid cars, and it has to do with the penalty mechanism, which is there. Now, 95 grams of carbon dioxide, what does it mean if you recalculate? Because you can't go to the fuel station and get the equivalent of 95 grams of carbon dioxide. So fuel consumption means if you want 95 grams per kilometer in carbon dioxide, yeah, that corresponds to something like 3.5 to 4 liters of fuel used per 100 kilometers, depending on that it's diesel or petrol. Yeah. So that's what it means. And then you know from your own experience, having a car which only uses 3 to 4 liters of fuel, there is not many people who own these kind of cars. It's not really on the market. So there is a problem with traditional cars. We need to get to more electric cars and hybrid cars. And what is now changing in 2021 is as I told you, the penalty mechanism. Yeah. And what does this mean? Well, for each constructor, car builder, they measure the average fleet average of carbon dioxide. So they take all the models and they measure how much it gives. And then for each gram on the average that is more than 95, they should pay per car which is registered. Yeah. So for instance, if your average is like 100 grams of carbon dioxide per kilometer, and this means 5 times 95 euro. This is 475 euros per car that you sell. And in this projection, it was made by JATO. This is an international organization which makes statistics for cars. And said, look, for the Volkswagen Group, they are missing about 26 grams per kilometer. So it's 125 there at the moment. So the penalty per registered car is 2,500 euros. And they built 3.5 million cars, more or less, in 2018. This would mean a penalty cost of 10 billion euros. Yeah. So here you see the penalty mechanism. And of course, this is driving all of these constructors to get this number down. That means you need to sell electric and hybrid cars so that the average of your cars is going down and that you avoid this penalty. Because the second number, this means that your car will get 2,500 euros more expensive for the same car between 31 of December 2020 and the 1st of January 2021. If you just look at the hard numbers. So cars will get more expensive because of this. Yeah. And this is a projection to see what car builders is on the road to do it quite okay and whatnot. And also we see some car builders like the Nissan Group. They are doing quite well because for many years already they have the Nissan Leaf as an electric car. They have hybrid cars. So some is doing well, some is doing not well at all. Yeah. So Volkswagen, they are trying to make a big leap now. They're probably getting much better and the penalty will get lower. The PSA group, that's Peugeot, Citroën in French group, they have a big problem because they sell a lot of cars, small cars, traditional engines, and they will not reach the target. So they will pay a lot. So they also put this here. What does it give in comparison to the profits? And for Volkswagen, this penalty would mean 76% of their profit would go to the penalty. But for Toyota, only 3%. And for Nissan, 19%. Yeah, these are very good already in electric car and hybrid cars. So they are low. It's quite okay. But for a lot of other, it's problematic. You see PSA Group, it's like twice their annual profit that they will have to spend. So it's very important. So these constructors, of course, will try to get these numbers down and improve their average. Yeah. There's also we see big constructors here. You don't see like Porsche or Ferrari or something. This is because there is different categories for the penalties. There's a big constructors. It's those who sell more than 300,000 vehicles a year. Yeah? And then the niche constructors, they do less than 1,000 cars a year. And they have separate rules. Okay, so what's the solutions to avoid these penalties? Well, make more electric cars, make more hybrid cars, because they keep the average carbon dioxide exhaust low. But also make more fuel-efficient cars. Yeah? And what comes with it, we should go back to more lightweight and smaller vehicles. And what is also done, and if you follow the market a little bit for cars, there is series of cars which is dropped. Like, so we have this legislation in Europe. Audi, for instance, they cut from their portfolio, like Audi TT and R8. They will not make it in the future because they don't sell many vehicles of that kind, but they bring the average carbon dioxide level of the constructor. They rise it to higher numbers, so they will be cut out, not replaced. And other constructors like Mitsubishi, they announced that they will not introduce new models on the European market and the UK markets anymore, except for electric cars. Because if not, they also have to pay the penalties. So with a new car. So it brings an avalanche of changes and disruptive changes in the world of making cars. And there is examples where it works. If you look at Norway, already for many years, they promoted electric cars and so on. And they have very strict rules. Their target is in 2020 already 85 grams per kilometer, which is 10 grams per kilometer less than Europe in 2021. So they are front runners, and they promoted a lot of electric cars and hybrid cars. And we see the numbers here. We see the diesel powered cars going down a little bit and returning a little bit because diesel is pretty good in the carbon dioxide thing. Yeah. Gasoline powered cars, that's the green line, is going down too. Yeah. Because they don't want this. Yeah? And then we see here the projection in Europe in 2025 is the next step. Then we go to 81 grams per kilometer, and in 2030, 60 grams per kilometer. So it is pretty problematic. But in Norway, they succeed because already in 2019, they're in this region. And how did this function? Well, that's what we see in this diagram. The number of battery electric cars and hybrid cars was growing exponentially. They put in a lot of effort to do this. So this is a composition of the car fleet composition by powertrain. And now we see, starting from 2011, the diesel compartment, so less diesel cars, was going down very much. Okay, the last couple of years stabilizing a little bit. Diesel cars, gasoline cars is going down, and electric drive and hybrid cars is going up quite a lot. So they made it. They're good. It cannot be just copied to every country, but so it means that it's not impossible, because Norway is a rather big country. It's got extreme climate. It's cold in winter, summer, sometimes hot. They have mountains, and still they are able to convert their transport sector and go to better solutions. Okay. So as a result, we've seen this year on the European market and worldwide an amazing amount of new cars with plug-in hybrid cars and electric vehicles. All to bring down the average tailpipe emission. It's not necessarily because these car manufacturers want to build these cars, but they are forced by legislation and by the market. Maybe the best example of this is the Volkswagen ID3 and 4. Volkswagen was forced to do this because they had the heritage of the Dieselgate, which they initiated. So they wanted to be front runners again. They have to build a good electric car for mass production. This is from Citroën DS. This is a Polestar, Volvo Geely, Volvo, whatever you call it. This is all new types which is coming on the market and which will be the next year will have a lot of success. Okay. A number of problems arose also from the way how cars was measured in the past. If you have a car, you know, in the book is written, this car uses like 5 liters per 100 kilometers, and in reality it uses 8. This comes from the test cycles. So up until now, up until 2020, we used the NEDC, is the new European driving cycle. It's not so new. It's from the 1970s. And now we start using the numbers coming from the WLTP. That's the Worldwide Harmonized Light Vehicles Test Procedure, which gives much more realistic numbers because the test has been altered a little bit. And on this test, on this NEDC test, there was based the Dieselgate. Volkswagen tweaked this test to get lower numbers than it was in reality. So there is difference in the test. The test now is longer, takes more kilometers. The average speed is gone up. So to be closer to real numbers, test temperatures have been altered, and a lot of other things is there. So there is less. This is the diagram how the test looks like. There is less stops. So a start-stop system will not generate as much benefit in this new test because this is much more realistic test cycle than it was in the NEDC. So we get better numbers. Also in the WLTC, you need to test the car as it is sold to the public. in the NEDC test, you could do a lot of tricks, like take off the mirrors, take off antenna, take off close gaps. So the car was taped so that there was no entrances for air in the car. If you had a car with electric possibilities, like a hybrid car, the electric energy which was used was not calculated in the exhaust numbers and so on. And tires could be special for the test, inflated to other pressures for the test than in reality. So it was a complete virtual number which came out. And now this is improved. We get a better test which is closer to reality. And in the near future will also be included in the test the real drive conditions. So then a car will be equipped with measurement sensors and will put on the road to also add to the test results in the lab. So we will get better improved numbers in the future. But the result is the WLTP test gives higher numbers than the NEDC test, than the old test. Bigger numbers now with the penalty mechanism is not so nice for car constructors, and it's an extra drive to rethink production of their cars and transmission lines. Okay, so what is the future directions then in automotive engineering? We don't know. We can think about it, but there is a lot of aspects. How will the car of the future look like? In car design, there is like some, every 10 years, there is a new style of cars. In the 1990s, everything was round. Now everything is quite boxy and with sharp edges. How will it look in the future? Coming together with other things. If you have a self-driving car, you can rethink the car, like you see down here. No steering wheel necessary anymore. And technology like Segway technology with 2 wheels only instead of 4 wheels. Could be. What will the roads of the future look like? If the roads is better, and other infrastructure, then the car could be more fuel efficient and other cars could be used. If we have self-driving cars, the road can be narrower. We don't need as much space because cars will hook up more or less and drive next to each other like a train. So you need less space for more cars. What kind of energy source will be used? Electricity, fossil fuels, but maybe also hydrogen and others. How clean will the car be for the environment? How much will it cost or allowed to cost? Self-driving cars is coming, and car sharing. It's another idea. If you go to work and you leave your car on the parking lot, somebody else could use it. So you need to build less cars in total, but the numbers of cars on the road will not diminish with car sharing. But the number of cars you have to produce will be less. So there is a lot of things coming up in this industry, in this disruptive change, which is now coming on very hard at the same time. In Europe, due to this legislation, also in America, there was a stringent legislation, except that President Trump, he gave a delay to the car manufacturers for 5 years, some time ago, which means that America will use an extra 500 million liters of petrol due to this, due to the delay of the legislation, the delay that Trump gave to the car manufacturers in America. Okay, so there is a lot of influencers there. So to improve this, there is a lot of things going on in the in this world of car manufacturing, and there is a lot of things going on the propulsion systems. There is a big interest for alternative fuels, energy sources, electricity, hydrogen, hybrids, and so on. So full electric cars, fuel cell cars, hybrids, plug-in hybrids, mild hybrids, complex hybrids, and so on, but also advanced combustion engines. It's also in the combustion engine construction, there is still possibilities to lower fuel consumption. Yeah, but a big thing which is still problematic is if you look at new cars, they all still look like old cars. Okay, they look somewhat rounder, they have but essentially the shape and so on doesn't change much, and this comes from the fact that they have to sell the car to customers, and if customers still want the same kind of cars than before, they will make the same kind of cars than before. Yeah? So we'll see a little bit further on. Okay, for instance, Mazda is a big constructor. They make brand new engines, spark-controlled compression, ignition engines, very new. They have electric cars coming up. They have hybrid cars coming up with different technologies, with batteries or with ultra capacitors, and so on. There is a lot of things moving. And Mazda, until let's say 2 years ago, Mazda was a performance car builder. They build a car which looks like a normal car for standard transport, but hidden in there is a big engine with a lot of performance. That was always their trademark. And now they also need to converge. So if we want to work on this, we want to work specifically on the fuel economy of the car. This is the big driver, because the primary energy sources, they will stop. Yeah? Predictions have been there for many years, but the date of when fossil fuels end is shifted a little bit over time. But more or less everybody in the field agrees on the fact that by 2070, which is about 50 years from now, all the oil will be gone in the world. Yeah? And that's a kind of optimistic prediction. Others say it's less. So that's, you could say 50 years is far away. Yeah, but this means that within now and more or less 20 to 25 years, fuel will be so expensive that most people will not be able to afford it, to buy fuel. And that is the problem, because then this horizon of 50 years is turned back to 20 years. And if you look in Ukraine, 20 years comes for a lot of cars close to the lifespan of the car. Yeah? So this is kind of a scary idea that there is a problem. So the primary energy sources, they are running out, yeah, and they are running out much more fast if we still want to put more cars on the world. Yeah? Okay, so there's a lot of things. Yeah? Fuel manufacturers, they want to sell, of course, their primary sources, but they also control fuel distribution. So, they will be the first ones to run out of fuel or rise the prices. What's other things which is important for fuel economy is, of course, the car manufacturers. Yeah? They should build good cars and fuel efficient cars. But if there is no drive, they will not do it. Drive comes from government and drive comes from customers. Yeah? So it will be a crime to keep driving a Porsche or a Ferrari, which uses 2 to 3 times as much of energy and fuel for the same purpose, namely transporting a person from place A to B. So there should be done something. Government is, of course, important. They impose laws, which is good, so that they force cars manufacturers to deal with it. Yeah, but they also influence infrastructure, and they also influence the end customer with taxes. Yeah, in Europe, all over Europe now, you have a penalty as a customer. If you buy a diesel car, you have a penalty. You should pay more taxes than if you buy a petrol car or electric or hybrid car. Yeah. Okay. So development of cars is much more than just technological development, which we look at as engineers, of course, but the number of stakeholders and players who define the car, who define the design of the car. There is a lot of things. There is a lot of people involved there. So if we want to look at a little bit at better fuel economy, in engineering aspects, we can improve technology a lot. What technology is necessary and available, and what's the implications for the user and the manufacturer and the maintenance. We can optimize design. How can we design our powertrain for the best fuel economy and other things? Because we want to keep up with some performance, but performance is this. Maybe it's not always important, but we have to do this. Drivability means how comfortable it is to drive the car. Safety demands. We also want the car very much to be safe. We want airbags in there and so on, but airbags, they weigh. They have a weight. So if you have extra safety demand, your car will be heavier, and it means more fuel. Okay. And the impact on the cost is also, cost of production is important. So car manufacturers, they cannot always go for the best technology and for the best scientific advance, because your car, in the end, you need to sell it. It needs to be commercially viable. It means you need to be able to sell it to people. Yeah? You have very good car from some points of view, like the McLaren. McLaren car built in with Formula One technology, with carbon structures and so on. It is the most fuel efficient car if you look at how much fuel do I use to get how much power from the car. So that's an engineering aspect. It is very fuel efficient in that way. But it's not fuel efficient to drive that car, because fuel efficiency only will get there when you go to the top performance of the car. And mostly you're not driving around in the streets at 250 kilometers an hour. So it's useless. So there is this different aspects. So if you look at a car, we use kind of a standard car. And what's the demands? We want an autonomous car which can drive and is not depending on a fixed power grid like a train or a tram. The refueling time should be low. We should be able to drive some time between refuelings. It should be able to transport some people and some payload. It should accelerate in a comfortable amount of time to 100 kilometers an hour. And we should be able to drive up a hill. Yeah. And this is customer demands. But here is a problem. If we want to accelerate a lot, it means a lot of power in the car and a lot of fuel consumption. So maybe we should also rethink society and the demands for a car. And a car is a complex device. If you open up the boot of a car from the 1970s, it's empty. You see a small engine or a big engine, and beneath the engine, you see the ground, the road. If you open a new car boot, you don't see anything. You all see technology sitting there. So it's a complex device. There is many components. Where to go optimizing to get the best thing. And if we have a look at the energy system, we come from primary primary sources, fossil sources like oil and gas, nuclear and sustainable, so wind and solar energy. This gives the well-to-tank efficiencies and production process. Now we have well-to-tank. Yeah? Our energy is stored on board of our car in a battery, in hydrogen, in a fuel tank. And then we convert it to the car. This is the engineering aspect. We convert it into mechanical energy to drive the car. Yeah? So, and then there is the energy consumption of the car. Yeah, the car drives, but then you have the energy consumption. This is set by the driver. Yeah, and we have energy waste if we brake. We make thermal energy, the brakes heat. This is a loss of weight. The tires, they wear out, the engine drag, and the way person drives the car. If you always want to accelerate a lot and want to drive maximum speed, your fuel economy will go down. You use more liters per 100 kilometer. So that's all there. So if you look at engineering, we can only control this process. The upstream process is not for the engineer who is making the car or the car industry. This is the producers of energy. Yeah, the driver is the driver. If I make a car, some people will drive this car and use 6 liters per 100 kilometers, and others will need to use 10 per 100 kilometers just because of the driving style. So these aspects, that's where engineering and also technical universities have to work on. Yeah, but here is a big potential. Yeah. If we can convince society that we don't need a big car with a lot of power, yeah, then we will have a lot of gain. Okay, so everywhere there is losses, of course. Yeah. So if you see fuel economy, yeah, there is a lot of things which can influence it. From the driving profile, speed, acceleration, and drivability, what does the driver expect from the car? From the vehicle, mass, rolling resistance, aerodynamics, size of the car, because this comes a lot with mass. The gearbox, the engine, the fuel itself, yeah, and then the energy availability, we already talked about it, and distribution loss. How much energy is lost when you distribute fuel? You know, at a petrol station, the ground is always soaked with diesel and petrol and smells. Yeah, this is a distribution, to name one. But the same exists in electricity and so on. Yeah. So there is a lot of things, and automotive industry is working on this, but it's also very important because in Europe, automotive industry is about 2.5 million jobs. Yeah, so that's also a political problem because politicians don't want to go in too much against car industry, of course, because this is their voters who work there. Yeah. So the primary sources, I already told you, this is some prediction in this work. National Geographic is quite well-known source of information. You see that the Canada's reserve includes oil located in sand fields, because every oil they have will be depleted, will be gone by 2060. Yeah, and it's similar curves for all over the world, of course. Dus in Canada, it's included, and all the other countries here. And we see there is depletion of all the sources. Some is already gone. Yeah? And some is nearly gone. So we have the problem. And this means that once you get here somewhere in the middle, yeah, in 15, 20 years, prices will rise so that nobody can afford petrol, only the happy few. Yeah? So fossil fuels is depleting not only oil, but also the rest. So for nuclear or for electricity, we can use other sources too. I'm not sure if I'm still in time.
Yes, you have 15 minutes.
No, still 10 minutes left. I can't
15 minutes, Peter. So
I can't see the chat for one reason or another. So I don't know if there is.
No, there are still no questions. And
okay.
If they will appear, I will tell you.
Yeah. Okay. Great. Okay,
so if you have any questions, please write it in chat, and later, yes, you could have an answer on them.
Okay, so primary energy sources, there we run into the problem of the fossil fuels, as I already explained, and we see here. It's a little bit scary to see this, because like even 2057, so when the last oil will be used, that's not so far. It's 30 years from now. Like the average student will be then 50, more or less. So that's not so far in time. Okay, there is also renewable sources, solar power, hydropower, wind power, and so on. This is also explored, of course, but there is the one thing is the investment to make it. Second is the possibility. Like for hydropower, you need a country where there is some height difference. You have in Zaporizhzhia a nice dam. Yeah, that's a difference of 40 meters. But like if you look in Belgium, most of Belgium is below 50 meters above sea level. So it's tough for us to find a height difference. Wind is also a possibility, but a windmill is big, takes a lot of space. Solar panels takes a lot of energy and precious metals to build solar panels. So there is also some restrictions in using this. So at the point of the upstream processes, we have to convert it to something we want to use. Oil needs to be converted into diesel and gasoline. We also have alternatives like biodiesel and methanol and alcohols. And then there is alternative fuels, hydrogen, methane gas, compressed natural gas. And we have batteries as an energy carrier. And what do we want? We want high energy density. It means we want to have a lot of energy on board of the car to get a big range to drive far. We want to have higher power density. This means the power should be released in a short time. It should be possible to have some acceleration and drivability. We should be able to refill simple and fast. We should have energy source which is low on environmental impact and low on infrastructure. Yeah? So there is a lot of demands. And if we now recalculate what's there, so we can do this. If we look at the bottom, we have a formula. This formula gives for a vehicle. We will not go into make this formula now, but if we calculate this formula, we see for a standard vehicle, more or less a mass of 1,500 kilograms, a car, this typical kind of full car like Ford Mondeo or something in this range, with a modern car with some aerodynamics and so on, then we get this power demand. And this means that we need something like 50 megajoule to drive 100 kilometers. And we see aspects of aerodynamics. Yeah, that's the first term. Size and aerodynamics. Second term we see here is depending on the rolling resistance of the car and the mass. Yeah, this is resistance. And in the end, we have acceleration. And there is the mass of the car is very important. And if we recalculate all the way down from how much energy we need, and if we have to convert it, starting from oil, for instance, if you take oil, we have to refine it and transport it. and then have to convert it to mechanical energy, then we come with a diesel car to something like an efficiency of 20%, meaning that only 1/5 of the energy stored in the oil is used to drive the car. Everything else is wasted. For a spark ignition engine, so for petrol car or CNG car, so compressed natural gas car, this runs in the something like 15 to 17% only. It's even less. Yeah. For electric cars, the picture is a little bit different. Yeah, because an electric drive is very efficient and so on. But some other thing is not very efficient, like making from uranium in a nuclear power plant, making electricity. We only use 30% going to electricity, means 68% is wasted in heat. Huh? So these numbers is important to find out how much is the overall efficiency of our system. And if we recalculate to how much carbon dioxide we then generate to do this. So if we use a diesel car, and then we have about 21 kilograms of carbon dioxide per 100 kilometer. Yeah? This is more or less what it means. If we have a petrol car, gasoline, this means for the same car, yeah, and the efficiencies, we come to 25 kilograms. So that's an increase of about 20%. If we use natural gas, we come to 20 kilograms. So diesel and natural gas cars is more or less the same for the carbon dioxide exhaust. Yeah? So this is the reason why diesel was a number of years ago very successful in the consumer eco lines. Blue tech lines from constructors and so on was all based on diesel. They lost it with the Dieselgate because there was in other exhaust gases was a problem. Okay, if we look at an electric vehicle, and we have the same vehicle, yeah, and we go to nuclear generates 0 kilograms of carbon dioxide. Yeah, so that's very good. If we make electricity with natural gas, we have about 8 to 10 kilograms of carbon dioxide. If we do it with coal, we generate 29 kilograms of carbon dioxide per 100 kilometers. So if your electric car uses electricity made by coal, you have these huge numbers, yeah, these big problems of your carbon dioxide. Yeah. These numbers is a little bit different from the website I showed before because they calculate a little bit a different thing. So we cannot just compare from the website and this number. It's because the calculation is a little bit different. Okay, so but this is interesting numbers, of course. We should be careful to see how the energy mix is to make electricity to find out if it's okay or not to use our electric car. So if you look at environment, the prime objective would be decarbonize road transport. We have here a car. This is a Nissan Leaf. This is more or less like the standard car. And if we charge it from national grid with a mix of gas and so on to make it, well, if we look at a gas-fired power electricity plant, then we generate about 160 grams per megajoule. And if we then recalculate it, we come to about 100 grams carbon dioxide per kilometer of this electric car. Huh? And so that's in the same range as what is in the leaflets from traditional cars. Yeah? But here is taken into account, of course, also all the losses before. Yeah? So losses comes from getting your primary energy source, converting it, producing, this is production, getting it through the wires to the home and to your car and driving. There is a lot of losses here. Yeah? The amount of losses, for instance, between your house and the power plant, this in Europe, in the power grid, this accounts for a loss of approximately 10% of your electricity. In the high voltage systems, so the big pylons scattered all over the country transporting electricity, you will have a loss of something like 4%. But in the low voltage section, going from the pylons to the low voltage system, 240, 400 volts systems to your house, we have a loss of another 8%. So more or less. So that's quite a big loss, which is sitting there. Yeah? Transformation to electricity also gives a lot of loss. So we have to take it all into account if we want to know the numbers for the electric car. And you should have the same for the petrol cars and so on. But in the petrol car, in the leaflet, you only have a number, and it doesn't take into account everything here. It only takes into account the driving. Yeah? So you cannot just compare these results 1-to-1. So this looks big. It is substantially big, but it's still better than for the same car with petrol. Okay. So if you want to read more about it, I indicated here some websites, which is very interesting. There is a website from the Dutch government. That's maybe not so useful because it's in Dutch. But the second website is from the American government. And there you can fill in your car type and brand and say where you live in America. And then it will calculate for you the carbon dioxide numbers, which is very interesting to look at, comparing places in America where they have a lot of nuclear energy or sustainable energy and where they have a lot of coal-fired power plants. Okay, so coming from European statistics, there is also this year, the range of life cycle carbon dioxide emissions for different vehicle and fuel types. Yeah? Because it's not only the emission you have, you also should make the car. Yeah? And then we see here a lot of things. And then we see that the carbon dioxide to make an electric car is substantially bigger than for making a traditional car. Yeah? But we see that the gain is afterwards. Yeah? In a petrol and diesel car, we have fuel production, which generates carbon dioxide, and we have the use of the car, yeah? Which causes exhaust. Yeah? So for each type is different. And then in the electric cars, it's renewable energy, okay, fuel production, carbon dioxide exhaust is low, and emission when using it is 0. Mixed electricity and coal. Yeah? So if you look at a country where you have electricity coming from coal, the complete life cycle carbon dioxide emission from your car, it far exceeds those from a traditional engine. So like in Poland, it's a bad idea for environment or Estonia to use an electric car, because there you will be the most polluting one on the road. In Norway, where they have a lot of renewable energy and hydro energy, it is very useful to have an electric car. Yeah. And in most European countries, yeah, France, Belgium, the Netherlands, and so on, it's also better to have an electric car. Yeah. Germany is more or less the same, but this is the average all over Europe. Okay, so that's something to take into account and to think about. It's not only what comes from the exhaust that's important, but you need to look at a complete picture. And most studies show that electric cars is, in most countries, except like Poland and Estonia, in Europe, for instance, electric cars is better if you keep to a moderate electric car. If you want an electric car like Tesla S or Audi e-tron with a very big battery, it's very bad because this green part will grow substantially. Yeah? But cars with a range up to 300 kilometers, more or less, electric cars is always better to use, except in Poland and Estonia in Europe, and about the same in Germany, as a car with an internal combustion engine. Okay, there is other cars too. Yes.
It's already time. Do you have a lot to... Yes, please.
I have about 30%.
Just like to finalize.
Just a second.
Sorry to disturb you.
No problem. I was just I will be rounding up. So if you want to go to better fuel economy for cars, we should improve energy consumption in the cars. And this means improve time to vehicle efficiency with better engines, better drivetrains, and especially on the vehicles to mile efficiency, get a better idea of how to use the car. Yeah. And so there is a lot of things about it, but I just want to go to maybe we need to rethink a lot. That's not important. Well, okay. So is there a future for personal transport and for things to be solved? Yes. Yes, there is. We can work on it. And especially for city cars, we should go on the road for electric cars. We should go for a road on downsizing all cars, make them smaller, more lightweight so that they don't use so much resources and fuel. We should go for autonomous driving because a computer is much more stable in getting a fuel economy car than your foot is. We can go for shared cars. We can change mentality of people toward expectations. We don't need a car with 200 horsepower that just to brag in the pub and say, my car is bigger than yours. It's not necessary when you drive a car. So we should rethink society, and we should think about other methods of transport. Yeah? For instance, electric bicycles. And that's the last slide I will use. If you look at an electric car, it uses 15 to 20 kilowatt hours per 100 kilometer. An electric bicycle uses 0.4 to 0.7 kilowatt hours. So you see that this is like 30 to 60 times much more fuel efficient. A high-speed electric bicycle uses a little bit more, but still 15 times less than an electric car. And even an electric scooter on which you don't have to pedal, is 5 times more fuel efficient than an electric car. So we can keep some personal transport also in the future if we go on the right path to redefine a number of things. And okay, I can imagine that you say, but in Ukraine, my bicycle is not very useful in winter because it's cold. Okay, but maybe you can use it in summer. And in winter, you can use public transport or a car, a small car, just to bridge the cold period. Okay. Thank you very much for listening to me. I hope it was interesting and that you liked it.